Hey, ladies and gentlemen, welcome to 9-4. We're looking for a quick warm-up just to get our brains ready. If we look at the three graphs, we're trying to find out which one is a two solutions, which one has one solution, and which one has no solutions. Hopefully from what we talked about from 9.2, you guys are thinking to yourselves, oh my gosh, this is super, super simple. And 9.3, of course, as well. So if I look at this, there's only one spot where it crosses the x-axis. That's the one solution. If I look at this guy, there's two spots. That's the two solution. And on this parabola, there is not a spot where it crosses the x-axis, so that's the no solutions. So just to get your minds thinking again about math, that's what we were looking to have happen there. So the big idea for today is we're talking about why can't a negative be thrown out as a solution to a real world problem. And hopefully we'll be able to figure that out here from our examples today. So the process that we're talking about today is called completing the square. To complete the square, there's a couple steps that we have to do. Number one, we have to have our equation be isolating the x squared plus bx part of the problems. Step one, we're going to find the b over 2. So we're going to divide b divided by 2. And then we're going to square the answer to that and add it to the end. So when we have our x squared plus bx plus c, the answer after 3 gets added into the c. And we'll show you that example here on our very first problem. So our job is again to find what b over 2 squared is. So we plug that in. It's going to be a negative 12 divided by 2, and then we're going to square that. A negative 12 divided by 2 is a negative 6, and a negative 6 squared is a positive 36. Now we're going to substitute that in for the c, so we're going to be left with our final thing here of a plus 36, which goes in for our c. So we have an x squared minus 12x plus 36. Now this should be something that we recognize as a perfect square trinomial, because you guys should see that this is going to say an x minus 6 squared, because it's a perfect square here, a perfect square here. It's that x squared minus 2ab plus c squared. So that's what we have looking at for us on this example. All right, let's try another one. This one's a little bit more difficult and it involves a few more steps. So like we talked about on the very first screen, is our job is to isolate the x squared plus 6x. So when we have our x squared plus 6x that we want to isolate, we need to remove the plus 5. You remove it by subtracting 5 from both sides. That gets us to an x squared plus 6x is equal to 7. Now our next step is we're going to use that b over 2 squared stuff. So b is 6 divided by 2 gets us to a 3. We're going to square it. And 3 squared is a 9. So that's what my c is equal to. So when I figure out that c is a 9, I'm going to add that back into both sides of the equal sign, because math is super, super fair. So we have an official answer here so far of an x squared plus 6x plus 9 is equal to, and I'm running out of space here, is equal to, so plus 9 here is equal to a 16. Now my next steps here, folks, is we should be noticing that we have a perfect square trinomial here. So this turns into one of those beautiful answers of a x, square root of this is 3, this is a positive, so it's going to be x plus 3 squared is equal to that 16. Now our job is to solve this. We use that square root property, so we're going to take the square root of both sides to get ourselves an x plus 3 is equal to a positive or a negative. Square root of 16 is 4. Now from here we have two problems left to do. When I was taught about how to do these things, there's this plus or minus sign was called taking the high road and taking the low road. So we will solve both of those individual equations. So we're going to have a x plus 3 is equal to a 4, and an x plus 3 is equal to the low road of a negative 4. Now we can do all of this math at one step because it's the same kind of stuff happening to x. So we're going to subtract 3 from all sides of our equations. So that gets those to cancel. So x is going to be equal to a 1, and x is going to be equal to a negative 7. Those are the two solutions that x could be. So if we were to graph it, the two spots where x crosses is going to be at a negative 7 and at a 1. So you'll be able to use this information just like we did in 9.3 and 9.2 and in 9.1. So use those steps to help you solve this multiple choice question for you to put into the Google form. And then we will try another question here that's just one step even more difficult. But it's not really that more difficult because it's just adding one thing to do. So step number 1, we see that all of my terms are even, which means I can divide all of my terms by a GCF of a negative 2. So when I take out a negative 2, I'm going to be left over with an x squared minus an 18x plus a 5 is equal to a negative 12. So that's what's left over after we divided out a negative 2. So again, just like last time, our job is to isolate the x squared and the x. So we're going to have to get rid of the 5 to isolate that x squared minus 18x. So we have an x squared minus 18x is equal to a negative 17. Our next job is to use our b over 2 and square it so that we can find the completing of the square part of things, because we're trying to make a perfect square trinomial. So we have to complete it by using that formula of b divided by 2 squared. So b is an 18, a negative 18, divided by 2. So that turns into a negative 9, and then we're going to square it. So our c is equal to an 81. Whoopsies, I wrote 18. So our c is equal to an 81. That gets added onto both sides of our equation. So we're left with an x squared minus an 18x plus an 81. And 81 plus a negative 17. Just double check on my calculator. Oh, there's a smiley face on this one for some reason. 81 plus a negative 17 is a 64. Perfect. Just want to make sure that's a 64. And we should be, again, noticing the pattern here, that this is a perfect square trinomial. That's going to be that x minus 9 squared. Because if we were to FOIL this, it turns back into that one because we take the square root. This is a subtraction sign. So we know that the middle is going to be a subtraction, is going to be equal to a 64. And now our next task, just like the previous problem, is to square root both sides. X minus 9 is then equal to a positive and a negative 8. So again, that's that high road and low road thing that we talked about in the previous problem. I'm going to have two equations to solve. X minus 9 equals a positive 8. And x minus 9 is equal to a negative 8. So we solve that by adding 9 on all sides. Oopsies, forgot it over here. And we get ourselves to a nice, beautiful final answers that x is equal to 17 and that x is equal to 1. And those are the answers, those are the roots to our parabola if we were to look at the graph. Now folks, that's what the assignment is like today. Hopefully you guys will find that fairly simple. The process is the same. So you have one last problem to try to do by yourselves. We'll go over these things again tomorrow in class. We wish you the best of luck. This is Bermination signing off.